Hmm. Trigonometry, Chapter 2, Acute Angles and Right Triangles, Section 1, Trigonometric Functions of Acute Angles, Video 9, Solving Problems Using Special Angles. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we learned about the 30, 60, 90 triangle and calculated all trig functions of 30 degrees and 60 degrees. And prior to that, the 45, 45, 90 and everything about 45 degrees. In this video, we saw problems using these angles, both 30, 60, 90 and 45, 45, 90, and the values of their trig functions. For example, solve for x and y. Here's a pretty straightforward question. We have a triangle with a hypotenuse 9, a 30-degree angle, opposite side x, adjacent side y. Notice we have a 30, 60, 90 triangle. We know the trig functions of either acute angle, but particularly the 30-degree angle. So to capitalize on this, we set up a trig function that connects the given angle, 30 degrees, to a given side, the hypotenuse, and either unknown side. So we're going to set up a trig function connecting 30 degrees, 9, and y. Excuse me, 9 and x. We'll do x first. How is x related to the 30-degree angle? Well, relative to the 30-degree angle, x is the opposite side. And since we're also using the hypotenuse, let's use sine and set up sine of 30 degrees equals opposite over hypotenuse, which is x over 9. But we know the value of sine of 30 degrees. It equals 1/2. Go look at the 30, 60, 90 triangle. So we can replace sine of 30 degrees with 1/2 right here and get 1/2 equals x over 9. That's an easy equation to solve. Cross multiply to get 9 equals 2x. Divide both sides by 2 and x equals 9/2. Pretty straightforward. We can find y the same way, but using cosine since this y is adjacent to the 30-degree angle. Cosine of 30 degrees equals adjacent over hypotenuse, which in this picture is y over 9. But cosine of 30 degrees is the square root of 3 over 2. So we'll replace cosine of 30 degrees with the square root of 3 over 2 and proceed to solve by cross-multiplying. 9 squared root of 3 equals 2y. And then dividing both sides by 2 to get y equals 9 squared root of 3 over 2. Pretty straightforward. Just got to set up the right trig function based on the angle, a side you know, and a side you want to know. Now, in general, any 45, 45, 90 triangle or a 30, 60, 90 triangle can be approached similarly if enough information is provided. You need an angle on at least one side. For example, find the missing values on this picture. Notice we have both triangles, the 45, 45, 90 triangle, one of whose sides we know, and a 30, 60, 90 triangle indicated by the 60-degree right triangle, but we don't know any of the sides. Now, instead of showing all the details, let's sketch out a plan of attack. First, observe that we have to start with the 45, 45, 90 triangle since we do not currently have any sides on the other triangle. But because the 45, 45, 90 triangle is isosceles and we know one leg is 15, we know the other leg, A, is also 15. And we can find C by either the Pythagorean theorem or by using any trig function of 45 degrees that involves the hypotenuse. So you got a few to choose from. So let's say we know the value of C. Then we have one of the legs in the 30, 60, 90 triangle. Now, since C is opposite the 60-degree angle, we could use sine of 60 degrees to set up an equation involving C, the opposite side, and D, the hypotenuse. Afterwards, we could find B using any trig function involving adjacent. For example, at this point, we would know D, so we could set up cosine of 60 degrees equals B over D. So I just want to lay out the plan and not put all the details in there. Now you try. Pause the video and try the following. Find the missing sides. Notice that we have a 30, 60, 90 triangle on the left with one of the sides represented. The hypotenuse is 24. And a 45, 45, 90 triangle on the right. Pause the video, see if you can find A, B, C, and D. This one's going to take a little time. All right, here's your fair warning if you haven't paused the video to try to solve it. Solution in 3, 2, and 1. I'll briefly discuss the solution. In the 30, 60, 90 triangle, we could set up cosine of 60 degrees equals a over 24, and sine of 60 degrees equals b over 24. That would give us a equals 12 and b equals 12 times the square root of 3. Then in the 45, 45, 90 triangle, which has b as a side, b and d are equal because they're the legs of an isosceles right triangle, and so they're both equal to 12 times the square root of 3. And to find c, we could either use the Pythagorean theorem, or we could use cosine of 45 degrees is b over c, but b was 12 square root of 3, and we would get c equals 12 square root of 6.